Hello. Welcome to the next session at InflectraCon. In this talk, we're going to explore protecting software from security vulnerabilities by inoculating your software at birth. I am Peter Hesse, the Chief Security Officer at 10 Pearls. Remember that if you have any questions during or after my talk, please send them via a chat window for this session. So in this talk, I'm going to start with just telling you a little bit about me and the company I work with. What is inoculation? Why? What are we trying to inoculate against? How do we do it? And what are the benefits we get from inoculating our software at birth? And then I'll wrap up with some next steps and action items for you. So as a brief introduction to myself, as mentioned before, I'm Peter Hesse, Chief Security Officer at 10 Pearls. Prior to being at 10 Pearls, I founded and ran Gemini Security Solutions for about 13 years, working mostly in the financial, healthcare, and biopharmaceutical industries. We were acquired by 10 Pearls in 2014 to provide security throughout the development lifecycle. 10 Pearls is an end-to-end digital technology partner that's helping organizations solve business problems through the use of technology. We're based just outside of Washington, D.C., and have a global team of over 500 people with development centers in D.C., Karachi, and in Medellin, Colombia, and sales offices in London and San Francisco, as well as Dubai. We work across a number of different industries, including healthcare, education, energy, and the financial sector. We like to use the term intelligent experiences to describe the software that we build because we use disruptive technologies such as artificial intelligence and machine learning, augmented and virtual reality, and others to create highly usable, secure solutions. But enough about us. Let's talk about what we mean by inoculation. Of course, the best thing to do when you're not sure of the definition of a word is to go straight to the dictionary. As you can see in the dictionary definition, especially the parts I've highlighted here, inoculation is talking about treating, preventing, or protecting from disease. What is the disease that we're talking about in this situation? Of course, it's security vulnerabilities, having problems, having hackers, having data breaches, and those sorts of things. By the way, when this talk was proposed, I had no idea that inoculation and vaccines would be ending up as such a hot topic here in the later part of the year. Now, I think I'm not the only one here that's looking forward to hopefully getting an inoculation before too long. So again, the meaning of inoculation is about providing defense. We want to create a shield against attack. In software, that means we want to create processes and mechanisms that will shield us from potential vulnerabilities. Something that is an additional layer of defense above what we have by default. So as this knight here has demonstrated by putting on armor and carrying a shield, he's creating additional defense rather than just, shorts and a t-shirt to defend him against arrows and swords and so forth. But we're not defending against arrows and swords. We're defending against security vulnerabilities. Now, also when we're talking about inoculation, we have to remember that it is preventative and it is not useful when it is tried to be used reactive. In other words, you couldn't get a flu shot to protect you from the flu if you've already got the flu. Inoculation is something you have to consider and do in advance. So I'll give you an example. Have you ever worked on a software project and been ready to launch into production only to be denied or slowed down by the security department? Maybe they found something in a penetration test they did when you went into the production infrastructure, or they decided they didn't like your choice of a data storage mechanism. By working preventatively, by doing it in advance, you can avoid these types of situations. And of course, it's important to remember that inoculation is most effective from the very beginning. And those of you that are parents like me, you know that the sound that you're about to hear right after this picture is taken. With software, when we're talking about the very beginning, this means that the initial ideation and discovery phase. At many organizations, ideation and discovery are solely the responsibility of the user research and user experience teams. That's not enough for inoculation, unless your UX UI team are also security experts. When the idea for the software first comes into existence, we already need to be thinking about security. That means open communication and in the involvement of the security team right up front to participate in the ideation and discovery phases and to think about what could go wrong and what do we want to make sure goes right when we build this solution. So that's enough about inoculation. Now, what's the big idea? What are we trying to protect against? I'll give you just 3 main ideas that we're going to try to avoid when inoculating software, in addition to the obvious of data breaches and so forth. The first is to stay on the right side of compliance and other government regulations. I'm sure you guys are all familiar with HIPAA and the various fines that are associated with violations of regulations like HIPAA, GDPR, PCI DSS, which is the regulation in the payment card industry or credit card industry. HIPAA has fines of up to $50,000 per violation. In recent news, you may have heard that Anthem is paying a $16 million fine to HHS to settle a massive breach and the HIPAA violations associated with it. These fines associated with these different regulations are intentionally punitive. They're trying to enforce these regulations with the fear of lawsuits. They don't have enough investigators to go after everyone. And so they want you to be afraid of having to pay these fines. Hit these organizations where it hurts, in the wallet. Second, and this is especially true in the healthcare industry, we want to ensure that every dollar possible can be spent toward improving patient outcomes. That means we're trying to avoid the millions and millions of dollars that are lost every year to fraud, waste, and abuse. Fraud, waste, and abuse is a common term in healthcare if you're not familiar with it. When we're talking about fraud, waste, and abuse, we're talking about fraud, which is getting healthcare benefits that aren't deserved or you haven't paid for. We're talking about waste. We're talking about overusing services or practices or items that result in unnecessary costs to the entire healthcare system that have to be absorbed. And abuse is where we end up paying for items or services when they're not supposed to be paid for. There's no legal entitlement. So badly written software and poor software security can help enable any, and in fact, all of these fraud, waste, and abuse. Hackers could break in to defraud the system. They can create waste by overusing services and practices. And they can abuse payment mechanisms to redirect payments to themselves. And security vulnerabilities that can lead to ransomware can single-handedly take down entire healthcare systems, as we've seen. And when your healthcare system is taken down, that puts patients' lives in danger. Another impact is, of course, we've talked twice now about potentially high costs, financial costs. But what can have an even bigger impact is reputational loss. Having a widely publicized security vulnerability or data breach has led companies to have stock declines and reductions in foot traffic. Yes, big box retailers like Target and Home Depot were able to escape from significant security breaches with a stock downturn that lasted for a couple of weeks but then bounced back. Smaller organizations aren't so lucky. They can't be assured of continued survival after such a significant reputation loss. A recent survey I reviewed in preparation for this presentation found that 83% of consumers will stop spending with the business for several months in the immediate aftermath of a security breach or a hack. And 21% of those consumers, over a fifth, will never return to a brand or a business post-breach, which can then represent a significant loss of long-term revenue. Reputational losses have a double negative impact. An initial downturn, yes, in the short term, but they hurt your longer-term prospects by scaring people away from your brand. All right, well, Peter, you've told us the bad news. How do we do it? Okay, fine. I'll give you 5 good ways you can work with your organization to inoculate your software. The first is education. Education is absolutely key to inoculation. By the way, is anybody else jealous of the days that we could fit this many people in a conference room and have an educational session and talk together and brainstorm? But I digress. As I said, education is a key to inoculation. An important thing to help your team realize is that any bug can be a security bug. Any crash, any memory leak, any uninitialized variable can lead to a security problem. It can lead to an attacker escalating their privilege and becoming, root access of the system or administrator level access of the system. And it can lead to private or sensitive information being disclosed in an unauthorized fashion. So educating your team is key to make sure that they realize any bug can be a security bug. Second, remember that you need to consider security requirements right up front. Whenever I'm working with our team on a software development effort, and we're at that ideation and discovery phase and thinking about what it is we're going to be building, I'm always thinking about what is the information we're going to be capturing? What are we going to be storing, processing, and transmitting? How do we get it there? How do we need to protect it? And of course, what compliance or government regulations are going to come into play as a result of this? You have to think about that right up front, because you can make decisions then. Do we really need to store a social security number or a driver's license number? You might decide that, maybe I'm going to take that as part of the initial registration process to validate someone's identity, but I'm never going to store it. I'm not going to retain it. I'm going to use it ephemerally in a single call, and then it'll be disposed of and never used again. Another thing you can think about when you're doing these security requirements up front is to make sure that you have the right kind of architecture that's going to be able to address the concerns presented by this information. Again, making sure you're thinking about things like, do I need to store this in an encrypted fashion? Am I going to have the capacity to log things, log transactions in my solution, and so forth? I think it's important as you're gathering requirements that you're gathering these security requirements. We typically capture them as non-functional requirements, and we even create security-relevant user stories such as a user, I need to be able to change my password in case I don't think it's secure anymore. Or as a user, I don't want my identity to be stolen when I use this software. Many of you are probably familiar with the DevOps lifecycle. DevOps creates a continuous pipeline and it blurs the lines between roles. No longer do you have separate development, quality assurance, and operations engineers, but everybody has a hand in this pipeline. To do proper software inoculation, DevOps is a great foundation, but what we really need is DevSecOps, embedding security into the DevOps lifecycle and helping all of our team members think about security throughout the process. I'm going to give you 4 quick examples of where you can insert security into your own DevOps lifecycle and create a DevSecOps lifecycle. First, consider implementing static code scanning. Static code scanning can happen as an automated process. It can happen while the code is being written right in the IDE itself, or when it's being checked into source control, or when the solution is being compiled from source code into a compiled executable. Static code analysis static code analysis looks for common errors in the software code itself. For example, if your code accesses a variable which has not been initialized yet, if there are any pathways through the code that allow that variable to be accessed before it's been initialized, that could be a way to create a vulnerability in the solution, because another process may have filled the memory that variable is going to be pointing to. Providing this information right at the time of development, right when the software developer has created that line of code that has a potential vulnerability, can help not just keep bugs from rearing their head later in the process, but it can also help your software developers just become better at writing software. Help them think through these processes when they're reminded right in their IDE that they're potentially coding in a software vulnerability. It's like continuous training for your software team. Another way to add security into your DevOps lifecycle is to perform automated penetration testing. When code is pushed into a development, testing, or QA environment, you can have automated pen testing or automated vulnerability testing be part of your process. This automated testing can look for common flaws that are easily found by scripted utilities. It can even perform what's called fuzz testing, which is where the tool provides lots of nonsense data into things like form fields or API calls to see if the unexpected data can create an unexpected result. Those unexpected results, crashes in different ways, or unexpected outputs can, of course, be a signal that there may be a potential security vulnerability in that part of the code. As you move to deploying into production, you need to make sure that what you're putting into production is actually what you meant to deploy into production. The best way to do that is to verify these deployments are the correct build. There's a number of different mechanisms to do this. The most common that we see in DevOps CI/CD pipelines is the use of containerization with digitally signed containers. That way, the same container that you pushed into test and ran your testing in QA against, you push that same release with the same digital signature on it into your production environment, and you can verify that signature in both places to be confident that the production code is the same as that which you tested in QA. And of course, it's important to continue looking at the security of the solution after it's in production. The best start here, of course, is to perform logging. Capture those logs, store them securely, and then leverage intrusion detection, intrusion prevention, and SIEM or SIEM tools, security and information event management tools, against your production releases. These types of tools look for unexpected behaviors. Some of them work in a signature basis, looking for behaviors they've seen before that they know to be harmful. And some just look for behaviors out of the ordinary, such as this application server is reaching out to the internet to make a call that it's never done before, when normally all it does is call to the back end and reach to the database layer to get code, for example. Or maybe there's an unusual number of login attempts or failed login attempts coming from a particular geographic region or a particular internet service provider, or so forth. So these 4 ways, I think, are great ways you can embrace security throughout your DevOps lifecycle and create a DevSecOps lifecycle. DevSecOps is a great way to inoculate and provide defense for your software and solutions. Another key to inoculation is to teach your development team and really your whole software team the basics. A great start is the OWASP Top 10, which is the top 10 web application security risks. I won't read them to you here. They're widely available and widely known. Everyone on your team should learn this. You should be thinking about this when you're doing designs, when developers are peer reviewing each other's code, when architects or managers are doing code reviews of their subordinates' code, and of course, when the QA process is going through. Looking for things like SQL injections and broken access control are just so key to avoiding most of the security vulnerabilities we see in software. You want to encourage your team to think like attackers. If I was trying to break into the system, how would I be able to get to this sensitive data in a different way outside of the way that the application typically provides it? Is there any way that sensitive data might be disclosed? And if so, what mechanisms can I put in place to avoid it? Finally, if you can, it's a great idea to work to formalize your development practices by adopting one of the many common security-focused software development lifecycle frameworks. I've shown 3 on this slide. The first one at the top left is the CMMI, or the Capability and Maturity Model Integration. CMMI is a way to measure on a scale of 1 to 5 the effectiveness of your software development practices. When CMMI was developed, it was really developed with the idea of preventing errors and bugs in code. Well, as I shared earlier in this talk, any bug can be a security bug. So CMMI and you're improving your capability and maturity level is a great way to improve your security as well, because it's improving your software development practices throughout. Next, at the bottom left, Microsoft has published a lot about their trustworthy computing SDLC, which started with this book, the seminal publication by Michael Howard and Steve Lipner, called The Security Development Lifecycle. This is one of the first things I read when I started to get into application security, and really a lot of it rings true still today. Microsoft's trustworthy computing SDLC has been lauded for the improvements to security throughout the process. Yes, I know there are still bugs and we still have patch Tuesdays and we still have flaws in different software practices. But boy, haven't we come a long way from the days of Windows 2000 and Windows Vista to the modern technology and modern software that's provided by Microsoft. Last, on the right side, I show the team software process, which promises to give developers that implement it an order of magnitude reduction in bugs. How does it do it? If you can see all of those little filter activities on the right-hand side, at every level, at multiple levels, there's a defect removal activity that's set aside to find bugs and to remove them, and that's put into every part of the SDLC process. I got these three, and of course many more, are all published in a document put together by the US government's CISA, or Cybersecurity and Infrastructure Security Agency. I'll put a link to this list of these and other security SDLCs into the chat after this talk today. Okay, great. So we've learned 5 ways to help inoculate our software, but what are we getting out of this? What are the benefits? The first benefit is we can avoid waste. And I'm not talking about the fraud, waste, and abuse that I spoke of earlier. I'm talking as a former developer. Developers are lazy. We don't like to do extra work. We avoid extra work at any means possible. That's why we write functions, so that we can do the same thing again and again without having to do it manually multiple times. So how do we help developers and development companies avoid waste? First is to, again, think about things like, what are your compliance requirements and regulatory requirements up front? For example, if you are going to have to support HIPAA compliance, don't choose a database that doesn't support in-place encryption or on-disk encryption, at-rest encryption. Because HIPAA requires at-rest encryption of personal health information. So if you choose a database that does not support encryption, guess what? You're going to be doing a lot of work to undo that choice and rewrite your database code to speak to a different kind of database that can support the in-place encryption that you require. The second is just to, again, implementing DevSecOps can avoid situations where you find a bug, at the time you deploy into production. So let's think about when you find a bug in production. What does that mean? If you do a penetration test or a vulnerability scan against your production instance and you find a new bug, it means you have to go back into the development phase. That developer has to remember where that, what part of that code that might be in and what they were trying to do with that function and so forth. They have to go back into that development mindset. They have to find the bug. They have to fix the bug. You then have to fix your quality assurance tests that didn't find it in the first place. So anything that you find post-production, you need to be fixing your QA so that you can find it before you write the next release. And that might result in other bugs that QA might find, and you have to go back and fix even more bugs. And then, of course, you have to go back and do regression testing against the whole system to make sure that in the process of fixing those bugs, you didn't introduce anything new. And then, of course, you're redeploying and retesting the solution. That's pretty wasteful for a simple bug that could have been avoided if you inoculated the software in advance. The second benefit to inoculation is to improve your speed. And we just talked about eliminating waste, and that by its very own nature will actually increase your speed because you're not having to go back and redo things and change architectures and change implementations and redo regression testing and those kinds of things. By eliminating waste, we are by definition increasing our speed. We're getting that end product to the end customer faster. But in addition to reducing waste, you can also be faster when you consider your own release processes. Security departments these days are absolutely overloaded. Most organizations don't have enough qualified security professionals. If your release process is set up with security at the end of the process, if you recall one of the earlier slides, I like to call that kind of security team the Department of No. You go live into production, and their job is to say no, is to find a reason to say no. If you create that Department of No at the end of your process, that single-threaded silo mentality causes many software projects to fail or at least miss their dates. But instead, if you address security throughout the lifecycle, instead of trying to bolt it on at the end, you can release faster and you can release more confidently. And there's a third benefit to inoculating as well. you can increase the usability of your solution. You've probably heard the phrase, security and usability is a trade-off. If the solution is secure, it must be hard to use, or if it's easy to use, it can't be secure. This is simply a false narrative. By addressing the security during the design phase, we can make it secure and usable. We should make it easy to do the safe things and hard to do the unsafe things. I gave a recent example of an iPad medical record chart that could sit at the end of a hospital bed. It should be very easy and require little, maybe even no authentication for a doctor to quickly pick up that tablet and read the vitals of that patient. But it should be harder for them to use that same solution to get the information of a different patient that's not currently sitting at that bed. And it should be difficult, if not impossible, to use that same solution to export all of the records of all of the patients in the hospital. This is about blending security and usability together. We can do that when we think about security as part of our human-centered design process. And we engage our user experience team in the best possible way by including security and security user stories right from the beginning. So, we've been through a whirlwind talking about inoculating your software at birth. I have a couple of conclusion slides to help ensure you get the valuable takeaways from this talk. First, let's remember the mechanisms you can use to inoculate your software. First, education. Remember that any bug can be a security bug, and anything that can help you avoid bugs is going to help you avoid security problems. Second is to address security up front. Increase the lines of communication between your security professionals, developers, QA, user experience, user interface teams. Communicate, 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 and capture those security requirements as non-functional requirements. Third, embrace DevSecOps. Build security tools into your DevOps pipeline and give yourself an automated way to catch problems before they show up at the end of the process and create waste to have to go back and fix them. Fourth, teach everyone the security basics. Start with the OWASP Top 10. It's a great place to learn about the most common places that software goes wrong and how to fix them. It's all right there in a simple 10-page PDF. And finally, mature your operations to be able to implement secure SDL practices like trustworthy computing or increasing your CMMI level. And remember that inoculation is only good as a preventative measure. You can't do it afterward. You can't do it at the end of the process. It starts as early as possible, and those small investments that are made up front can help save you from huge costs down the road. I'm looking at you, Anthem, and your $16 million fine. I've shared 5 easy ways for you to integrate inoculation into your software lifecycle and really consider yourselves a security team, not just a software team. And if you get pushback, remember there's a strong return on investment when it comes to software inoculation. You can avoid waste, you can speed up and improve the usability of your solution, all while improving the security of the software. So with that, I'd like to thank you so much for joining me today at this session at InflectraCon. Again, feel free to send your questions through the chat window for the talk. Thanks for spending a few minutes with me today. I hope you enjoyed this session.